Okay, so with that in mind, we first had to determine if things are like, because you can only add together like terms. So in this instance, now we actually want to go ahead and add these up. So on first example, number 7, what is 1 root 3 plus 4 root 3? Okay, done this enough years, usually I get a few different answers. So here's the different answers I usually get. I get some people that say is 4 root 6. I get some people that will say it's 5 root 3. I get some people that will say it's maybe 5 root 6. Those are usually kind of my common ones. I might even get somebody that might say something like 4 root 9 or maybe 5 root 9. Those are usually, again, some of the answers that I hear for this first example. Well, let me pause and let's think about this. What is, give me a minute to bring up a sticky. Okay, so let me shrink that down a little bit. Okay, let's pause here. On my sticky paper, if I was to ask you what is 1x, oops, okay, why are you not? There we go. 1x plus 4x, I think most of you would probably say correctly 5x. You have 1x plus you have 4x's, they add together to give you 5x. So the same idea is happening with radicals. 1 root 3 plus 4 root 3, well, with that in mind, 1 root 3 plus you have 4 root 3's, that adds together to give you 5 root 3. So these are not correct answers. 5 root 3 is the correct answer, okay? Same thing's happening on example 8. Root 5, those are already like terms, so just take the coefficients out front and perform the operations, add them together. What's negative 2 plus a negative 4? Negative 2 minus 4 is negative 6. Keep the radical as is. That's it, okay? These first two are kind of simple. Now let's look at example 9. Keep in mind, are they like radicals? Do not say something like 6 in the square root of 15. You can only add like radicals together, and they are definitely not. So first thing we need to do is simplify. This is exactly what we ran into, I think, up here in example 4. They are not like radicals, so we need to simplify and then see if they're like to add together. So take 2 root 12 off to the side. Simplify 2 root 12 down. Now we've done a lot of prime factorization. So 2 root 12, the prime factorization of that is 2 times 2 times 3. That's going to simplify down to eventually 4 root 3. That 4 root 3, that does nowhere. That comes on down. So now we're asking ourselves, actually, is 4 root 3 plus 4 root 3, can we do that? We can. They are both like radicals. Add the coefficients together. And there's our answer now, okay? So if they're not likes, see if they simplify down, and then add them together. All right, number 10. Let's do it out. 18, let's see, 2, 3, 3. Negative 6 root 2. 50, take it off to the side. Do it as well. Pairs make perfects. So 20 root 2. Now, I've been doing this for years, so I go a little bit quicker on that. So take your time on it, but I promise you, you get a lot quicker on it because we're going to be doing radicals all year. These turn out to be likes. Negative 6 plus 20 is what? 14 and the square root of 2. All right, let's do the next one here. Let me get the sticky out of the way. Okay, 3 terms, 4 terms, 5 terms, who cares? First thing I notice is they're not appearing to be likes, but let's take that 28, because root 7 goes nowhere, root 3 goes nowhere, but root 28, that can simplify down. 28, simplify it off to the side, okay? Eventually that gives you what? Negative 2 root 7. And then we do have like radicals. 6 root 7 and negative 2 root 7. That adds up to be 4 square root of 7. Now that 4 root 3 is not a like term. This is like saying 4x plus 4y. You wouldn't add those together to say something like 8xy. That's not correct. It's already simplified. So same thing happens here. Don't say like 8 root 10 or anything like that. That's as far as you can go, okay? One more here. 5 root 3, 2 root 20 minus 5 root 3. So root 3s are obviously like terms, but let's simplify that 20 down. So 20, take it off to the side, simplify down 2 root 20. I think you eventually get 4 root 5. Like terms. Okay, those are going to combine together. Now, on this example, it's not meant to be a trick example, but I always have kids that kind of fall into this trap. Here's usually a couple answers that I see. Some students will say 4 root 5 plus root 3. Some students will say 4 root 5, just 4 root 5. Those are usually really, I say, the two big answers I see. One is right, one is wrong. So think about it, which one is right and which one is wrong. So it's those 5 root 3 minus 5 root 3. What is 5 minus 5? 5 minus 5 is obviously very much 0, okay? When I got the root 3's on there, you're saying now, well, what's 0 times root 3? What's 0 times anything? It's 0. So those 5 root 3's are going to cancel out. So the answer is 4 root 5. If you thought that was the answer, think about it. In front of that root 3 is technically a 1. So if you said that was the answer, you just told me 5 minus 5 is 1. I don't think that's correct. If it is correct, I didn't get the memo on that. 5 minus 5 is 0. So watch that out. Those are usually that's usually the mistake I see about subtracting like radicals. Okay, exact same term on that. All right, let's go with one more here. 5 root 24, take it off to the side and simplify. So 5 root 24 eventually gives me what? 2 and a 2 and a 2 and a 3, I believe. So that gives me 10 root 6. 49 is perfect. 3 times 7 is 21. 25 is perfect. Square root of 25 is 5. And what's 5 times 5? So I have like terms. 21 minus 25. 10 root 6 comes on down, and 21 minus 25 is negative 4. All we can do, those are only like terms.